Okay, perfect. So here we are at beCloudReady. We are a startup, and we basically excel at corporate trainings and train and hire programs. So we have run a lot of train and hire programs in the past, and so basically our role is to select people who are good at analytics methodologies and who have some kind of willingness to learn, and train them properly. And once they are trained, we try to get them hired, and uh, you know that's how we have established ourselves in the market. So today we are here for Spark. So let's first talk about us. So this is us. We, as we said, we are a startup where we do a lot of consulting projects. We have some artificial intelligence products as well in the currently under development, and some have already been launched in the market. And and we do a lot of trainings, as you can see. So it's a startup founded in 2015. We have a lot of AI and cloud products, as I just said. We provide consulting services to different companies. A few of our clients are primarily in the auto and retail industry, and some in the insurance sector as well. We do a lot of placements and training programs. So basically, the train and hire program is something that we do a lot. This some information about our contributor named Chandan. He is our chief data architect. He has more than 15 years of experience in software development, and primarily he is a data engineer, is a cloud architect and data engineering personnel. Extensive experience across RBC, LCBOs, multi-band, weather network, RICS, and so on and so forth. This is me. This is some information about myself. I'm the chief data scientist for beCloudReady. I have more than 15 years of experience in analytics and consulting, and I'm primarily the machine learning and the AI guy. And I extensively work with Apache Spark, basically PySpark, Python, SAS, and R. Right. Somebody wants to say something? I hear a lot of noise. Or let me just mute everybody else. Okay. So now we can. Okay. So this particular webinar is about a citizen data scientist. So basically, a personnel who can essentially bridge the gap between a data scientist and a data engineer. So somebody who knows data engineering a bit and who knows data science as well, right? So essentially, you cannot become both of equal measure, generally. Of course, there are surprises, but in general. What happens is normally that you are primarily a data scientist, but you can do a lot of data engineering functions as well, or vice versa. A citizen data scientist is essentially that kind of a person who is excellent as far as data science is concerned, but can also handle a lot of data engineering aspects of, creating an end-to-end software solution by using data science, right? So let's talk about the data landscape today in Toronto. So before this COVID, and of course, I expect that after everything is normalized, let's say by May end or something, the market will again bounce back because whatever is the pent-up demand will come in the market. But as of now, the data analytics market in Toronto itself is close to $2 billion, right? And the ICTC expects 43K plus big data jobs alone. Right? It is in 2020. Data professionals are at least paid 20% higher, right? And if you have skills like PySpark and good exposure in Python, not just some interview questions, but a bit more where you can actually and practically do something, then your salary ranges are really, really good. And now everybody is trying to hire people who are more or less a citizen data scientist kind of category, wherein you do not need a lot of support as far as getting your data and operationalizing your models is concerned. The traditional job roles till now have been data science, that you are just a data scientist. All that you can do is to develop some models. Then there is a data steward who is basically kind of doing a lot of data reporting and MIS and those kind of stuff, so that you can see what are the trends and publish the overall numbers so that the senior manager can do and look at the data sets and look at the trends and everything and decide what. Data engineer, who is essentially the person who doesn't care what is the insight in the data, but who cares about the verification of the data streams, who tries to ensure that the data is available in real time and the data is correct, right? And the data analytics guy, who is basically a portfolio analytics guy, who is looking at different kind of trends and different kind of pockets in the data where some things are not moving too well or things are going very well, and try to identify some patterns which can be very quickly and very easily explained in business language to the sales guys, to the marketing guys. So these are the guys who will essentially look at pie charts, graphs, and these kind of stuff. But if you ask them to do some kind of a predictive modeling, or ask them, okay, what will your revenue be after 12 months, they are not the people who can be dependent on, right? So this is how in the market there are different profiles or different roles of people related to data are already there, right? But now with the big data and cloud, everything has changed, because earlier, there were very fixed kind of platforms for publishing and for reporting. There used to be very different platforms, and for data extraction, there used to be very different platforms. And for predictive modeling and all, you used either SAS or R or IBM Spaces Modeler or so on and so forth. But now with big data, everything has changed, because if you go to Power BI, it is very well integrated in your Office, right? Office 365, right? You can very well just integrate it, right? So integration is the key now, right? So things are not secluded anymore. So if you know Python, then by extension, you are supposed to know PySpark, because if you don't, then basically you cannot handle a lot of data together. You also need to know, okay, what is the difference between Hadoop and Spark? You also need to know, okay, what are the cloud computing platforms? AWS, Azure, Databricks, so on and so forth. Okay. And then how do you operationalize your models once you have made it? So do you know Flask? Do you know Plume? And so on and so forth. And then more than just the buzzwords of AI and machine learning, do you really know about what is machine learning? Can you really develop a model on your own and productionize it for commercial purposes? So that's the trick here, and that's the fight here. Because that's the fact that all of us who are attending this webinar, somewhere down the line they want to switch their careers, get a nice job as a data scientist or something. Now the thing is, why should someone hire you? If you just know some codes, some lines of codes, and if you have just read on some training programs, you have just read something, okay, what is random forest and how does it create a tree? Everybody knows that. So if I am interviewing you, I will ask the first question, okay, what is random forest? You will answer it very well because you have already mugged it, kind of, right? But the moment I will ask you, okay, so this is a particular problem. This is a very peculiar kind of situation you are in, and this is how your variables are behaving. How will you decide which model to use? And then you will be gone. So for example, let me ask everybody a question. How many of you already know how to design a machine learning algorithm? Anybody who can say that they have developed a machine learning model before? Is there anybody in the audience? Guys, please open up. Is there anybody who has done a machine learning model ever? Okay. So, Amine, Burumand. So,
Yes,
so you have developed some models, right?
right.
So, what is the difference between precision and recall in a machine learning model? Have you heard these terms?
Yes.
Can you
Uh,
explain?
yeah, one of them, I think, precision showing the accuracy of the model.
Mm-hmm.
And recall is just showing the false positive rate and false negative rate. So one of them is accuracy, one of them is the precision, I guess. Yeah.
Hmm. So if you are in an interview and if someone asks you this question and you gave exactly this answer, do you think you should be hired?
No, I know it's not the accurate answer, so I forgot honestly about the exact.
Yeah. And you know what? Nobody can mug the answer. The reason is that it is so confusing that if you have just mugged it, I mean, I can give it in writing, you will never clear it. Because one more twist of the question and you will fall flat. The trick is until unless you have by yourself, if until unless you have designed a model and developed a model from really raw data, you will never know how exactly it is done. You will always be confused because mugging something is different, doing something is something different, right? So here we are assembled to actually do something and rather than just mugging it. Because if you just have to mug everything there online, available. You don't need to even bother, right? Now let's talk about the market trends. So as you said, now we need data professionals or citizen data scientists rather than just a data scientist or just a data engineer. And what it is a mix of everything, as I just talked. Right? So some of the key skills is, of course, everybody is talking about Python. Where did it go? Yes, Python, because you need a platform which allows you to develop a lot of advanced machine learning models quickly. Python is a platform which is supported by a lot of developers, so that all the new libraries and new methods of doing new algorithms are generally released in Python first. Data science is basically using Python as a tool and maybe a lot many other tools such as Excel, such as SQL, such as Power BI, such as Spark, to actually come up with a database story and do something end to end so that you can actually solve a business problem. Machine learning and artificial intelligence are just those models or the algorithms that you have always heard. But let me tell you, everybody talks about a neural network model. But making a neural network model which actually works and which remains stable over a few months is really not an easy thing. It requires a lot of experience. And I'm saying this because I have been working in this industry for more than 18 years. Right? So I know it very well. How hard can it be? What you go through in the training platforms and in the classes, it always works because no trainer will ever give you a data set on which making a model is very difficult. Why? Because he will waste time. Right? But in the real life, whenever your boss will give you a project, it will be a project which has never been done. Otherwise, he will not waste his time. Right? And that means that most likely your first few attempts are going to fall flat, right? And then you need to know, okay, why not an ANN model? Why should I make a random forest model? Why not a GBM model? Why not an XGBoost model? Or why not a reinforcement model? And whatnot? Then you need cloud because these days everybody is using cloud, so cloud resources to stage their data, to make sure that all the production is done in cloud and so on and so forth. So different platforms, maybe AWS is there, Azure is there, Databricks is there, Oracle is there. So many platforms are there. So it depends. More or less, their philosophies are the same. Then you have Apache Spark. So now today we are talking about Spark. We are assuming in a way that you know a little bit about Python, right? But let's talk about why should we talk about Spark in the first place? I mean, till now everybody was talking about Python. How come suddenly Spark? Why? Because Pandas, primarily where everybody works in Python, is a memory hog, and it's really limited by the hardware of the machine. So, for example, my current laptop is a 32 GB machine, 32 GB RAM with 12 cores, and even that sometimes crashes. And I do not work with a huge amount of data, I would say. I work with average amount of data, but let's say if I'm doing an extra retrieve model, sometimes my machine takes 1.5 hours just to optimize that model. Right? So it's a memory hog. Second biggest problem of pandas is that it at one point of time in one operation it uses a single core of the machine. So even if I have 12 cores in my machine, at one point of time it is only using one core of a machine, which means everything is loaded on the RAM only, and the cores are essentially the multi-threading is not being done. And pandas is not optimized for handling large data sets. Pandas is essentially written for doing something very fast and in a very easy way. Right? That doesn't make it very efficient. So if you have to design a model on, let's say, 10,000, 20,000 rows of data, it's very good. But if you have 10 million rows of data, then God bless you. Right? Essentially, any kind of for loops, any kind of functions, you have to be very careful what you are going to run, because I'm not saying that it will be wrong, but it will be so inefficient that it might take hours, maybe even days, to just complete something, and you might run out of memory because everything is loaded up. So parallelization of data is not enabled in Python by default until unless you are taking Python on to a cloud framework, and that too within something which uses the pandas library to the minimum. So that's where we are talking about PySpark, which is Spark basically using Python, which kind of solves all these issues. How is the Spark ecosystem? So Spark is, so basically even before that, what is Spark? So without wasting any time, so Spark is essentially a very high-end server for in-memory processing placed over a Hadoop cluster so that you can do a lot of parallelization of data. Following a MapReduce algorithm or a syntax, you can say, or whatever method you can say, so that whatever you are asking Spark to do, if it can process in the high-end in-memory processor, it does. That's why it is fast. But if it cannot do that because the data is so large or the process is so large, then it falls back to the Hadoop cluster and make sure that it always gets the job done without crashing or without failing. So traditionally, the Hadoop platform is a read and write platform. Every operation is a write to the disk or a read from the disk. That's why it's very, very time intensive and very, very network intensive. And that's why Hadoop is primarily used for a batch processing. So some program which is already written, very well established, very well operationalized. So you run it at night and by morning you have all the information. For that, Hadoop is very good. But if you have to develop something on the fly, no way. You cannot do that, literally. Because it's not designed for that. Right? There comes Spark, which has, as I said, a high-end server which can take care of a lot of near real-time requirements from the users, right? And Spark is originally written in Scala, right? But you can essentially code in Spark by using different APIs. One is Python, then you can use SQL within Spark. You can obviously write codes in Scala, which is the native language. You can code in Java. You can also write codes in R, though a bit limited as of now. And different libraries available within Spark are Spark SQL, which enables your SQL, Spark Streaming, which enables you to use streaming data, Spark mlib, which is kind of scikit, on Python. Basically, a lot of machine learning algorithms are available there. GraphX, which is for visualization of data. Spark R, which essentially supports your R, and data frames, which is your pandas data frames. So why is it supported and why is it so critical? It is critical because Spark by default works on RDD, resilient distributed data sets. So once you create a data set, you have written a program to create a data set, but at the back end, Spark doesn't necessarily create that data set every time you write a code. Essentially, Spark only executes something if it has to. Otherwise, it just learns how to create something without actually creating, right? That's called a lazy evaluation. How does it work? So in terms of processing engine, instead of just a map and reduce, that is filter and sort and then aggregate, what typically happens in Hadoop framework, Spark has much more. It has a large set of operations, a lot of transformations and actions, and they can be combined in any order. So it's not necessary that A leads always to B. B can also lead to A as long as they are making sense. It's an open source software, we all know. Support Java, Scala, and Python, we know. And original key construct is RDD, resilient distributed data set. So basically what happens is every time you ask Spark to make a data set, it creates multiple copies, right? It distributes the whole data set into multiple pieces, creates multiple copies, and stores it in different places, in different nodes in the same cluster, right? And then every time you run an operation, all these clusters work together and ultimately you get a combined result at the end. That's called the reduced part, combined result. What you get is the final work is actually done at a lot of nodes. So there is a lot of, there are concepts of like master nodes and slave nodes. You know, master nodes remembers who is doing what. The slave nodes are actually doing the things needed, the operations. Spark follows lazy evaluation. Basically, it doesn't take an action unless it has to, right? When you write, okay, read this file and create this variable, and then multiply this variable, divide by this variable. But you know, it will learn that you know you have given all these instructions, but it will not create those variables unless you ask, okay, tell me the average of this variable. What is the portfolio average of this variable? At that moment, it will go back and it will do all those 4 steps in one shot and then give you the final number. Right? So it kind of it minimizes the number of steps it has to do, and that's why it is very fast. Right? So there are different libraries and so on and so forth. Right? Now, important question is, uh, how do we do the Spark thing? Right? It's very difficult because just the installation of Spark on your machine is a Herculean task. You need to be really somebody to be able to do that. But it's not always the case. These days, a lot of online platforms are there which allow you to do it for free. There are other platforms which can essentially allow you to work with your own data uh, with Spark with a minimum payment or literally no payment, such as Databricks. But there's also a way of doing it on your own laptop. And when I say laptop, why should I do that? Because essentially what you are doing, you are kind of invoking a Linux environment on your machine, you know, by using a Windows subsystem. And then you are able to use multi-threading, you are able to use all the cores of your machine. So it is much faster than your regular Pandas. Right? How do we do that? So there are multiple steps. I'm just in very quickly and in a very short summary I'm giving. In your Windows machine, you need to have your Java installed. You need to set up your Hadoop home. You need to download the latest version of Spark, set the path, and then install it. And finally, after that, most important thing, even more important than the first part, is to install the Windows subsystem for Linux. Install Ubuntu on your as a native software on your Windows 10 without going to a virtual machine or something. Then install Anaconda and set the other data science libraries, right? Once you do that, then finally you are able to use Spark from within your Windows environment. Let me tell you something. Let me show you what I mean by saying that. Here I am on my Windows machine. I have kind of integrated Spark here in my Spider ID in Python. Now, if I just do that, I can see that I have just invoked Spark. I have started a Spark session, right? And then I just create um, an environment for Spark, right? This is a Spark session that I've just started. Now let me create a very simple SQL object. right? I just created a table, df, where there is a variable and that variable has taken a value of Spark. That's it. Now let me read some file. So here I'm reading a CSV file in Spark. If I want to see anything here, I can't see a TRN file. I just can't see a TRN file. Fine? Because Spark, when I'm saying that, okay, read this file, it just now it has stored how to read that file. And it's an RDD, it's not a data frame, so you can't see it here. Right? That's the challenge of working with Spark, because as a data scientist, we are just accustomed to looking at all these files that we load and that we read, and then just double click and open these files and look at what's there in the data. In Spark, you can't do that, right? You have to do a lot more, right? Essentially, let's say you have this, you can do like two pandas. You can convert it into a data frame and then see it later. For example, let's see what I'm doing. Within Spark, I'm using Python environment. I'm using Pandas as PD, and I'm creating a table, an explanatory table of OLS file. And I'm trying to see, okay, what are the features? If I open this file, I can see these are the different variables, parameters, and this is their mean, their standard deviation, their minimum, their maximum, and so on. So just to publish this, I had to go to Pandas. Basically, OLS is the original data, RDD that I read. I applied the operation describe, just like in Python. And then I applied two Pandas so that I can convert it into a data frame. And then I transposed it so that I can see it better. Right. Now, let me tell you how to do SQL in Python. Very simple. You invoke the SQL context. If you have done everything right, you can do that. You declare a table, your logis table, as a SQL table called table1. Now you can simply do a query. Let's say I want to create, okay, select star from table1 where housing is equal to yes. It's a very simple thing, right? So now I have created a data frame called P, right? And this is where Spark SQL is running, and it has selected from table1 all the rows where housing is equal to yes. And then again, let's say a separate thing called T, Spark SQL, where age is less than equal to 30. But if you see here, I can't see T. There is nothing called T. Why? Because now it's an RDD, which doesn't get converted as a data frame just like that. If you just want to see the top 5, just like head in Python, you can just print it here like this, right? But it's not a data frame. To write it as a data frame, you will have to write it. And let's say I want to do a group by. I want to do a group by of housing and then look at the count where I'm just selecting housing and count, and then I have to ask it to show. Once I do it, this is the Spark way of summarizing some data set and then publishing it on the driver, seeing it on the monitor. So housing, there are 3 categories of housing and their counts are like that, right? And so on and so forth. So this is how we can integrate Spark onto our Windows machine or Windows laptop and actually do a lot of things pretty quickly, right? So this is what we train in our program called Journey to Become Data Scientist, where our syllabus is like we start with very basic concepts of data science, and we tell you the maths behind it. We tell you what to use, when to use, how to prepare for something, starting with Excel to SQL Spark. So we teach you Python programming. We teach you Apache Spark. We teach you how to run some machine learning models on cloud. So basically Azure ML Studio, Databricks, Spark on Databricks. We teach you that. We tell you the basic concepts of Apache Hadoop. We tell you SQL on cloud, how to do SQL on cloud. And then this is just the training part. But the key part, the meaty part, is that we then give you a live internship where you work on a live project, which might or might not become a commercial project as well. And we do a job assist. Basically, we prepare you for your interviews. We take a lot of interviews. We send your resumes to relevant postings, and we make sure that you get calls for those interviews. Of course, converting those interviews is something that we will train you, but ultimately you you have to perform there as well. And once you get job placed, that's when is considered our success. Additional benefit, it's a money back warranty for the first week. The first class, which is going to start soon, I think, first week of April. And that is a free class, but you have to register with $1,000 so that only serious people can come here, and no time wasters, please. And then once you, let's say you have understood that first class and you are okay to take the plunge, then the original, the program overview is that there will be 6 to 8 weeks of rigorous training, combination of classroom, online, and assignment. Now, because of COVID, classroom will not be there mostly, will be online and assignment. Then from literally from the very beginning, you will get an internship on a live project and job assistance post your internship. And our success rate, if I have to say, is 80% within the first 3 months, 81% within the first 6 months. And we have never seen somebody sitting after this.